not a problem. Now, if you want to talk something or want to discuss some problem about the previous classes or anything, we can proceed, or we can proceed to our next lesson. Anything you have preferred? Anything, any doubts, any problem regarding the previous classes? Okay, anyone else? Okay, Dipesh. Uh, now we Okay, anyone else? Anything want to talk? Want to discuss about any doubts or any problems regarding the previous classes? You may allow to discuss about all those doubts. But if you don't have any doubts, then you can proceed to the next lesson for today's class. Okay, okay, I'm proceeding to the next lesson now. Just showing the presentation for today's class. I think now can see the notes of today's class, the presentation of today's class. No, the notes is visible. I think now I am proceeding to the next lesson or the next module, that is module 5, that is iron carbon system. Yes, iron carbon system is nothing but a simple phase or binary phase of iron and carbon. Okay, don't write anything in the chat box now. I have started the lesson for today. Please don't write anything in the chat box. After the lesson, you may allow to discuss. Okay, and don't write your roll numbers and name. I'll take the attendance from the Google quiz. Now, please stop your audio and I will start the lesson for today's class. That is, today I am starting module 5, that is iron carbon system. That is nothing but a simple binary system or two element system. About the two element system or binary system we have discussed in the previous classes, that is nickel and copper alloy, that type of system. This is iron carbon system. And why this iron carbon system is so important to discuss, that iron carbon system means in steel, one is the most important material for our structural material, that is steel. Steel is nothing but the mixture of iron and carbon in some specific percentage. That's why this iron carbon system is most important to discuss in this subject. Okay. Now, to understand about the iron carbon system, we have to first analyze and we have to first understand the property of iron, pure iron. We have to understand the properties of pure iron in a crystalline structure. I think ma'am, Anindita ma'am have discussed about the crystal structure of different metals, and regarding that thing, that crystal structure of metals, this iron is obviously a metal, and you have to understand those crystal structure also. I'll not go in depth about the crystal structure, but we have to discuss about some portion of crystal structure of iron. Okay. Now, for that, you may study your, I think, second module, that is crystal structure of metal. If you have any doubt or any problem, you may discuss about that crystal structure. with me or with Anindita ma'am. Okay, and please discuss if you have any doubts or any problem about any portion of your syllabus. Okay, now first of all, I am going to discuss about the property or crystal structural property of pure iron. And to understand the structural properties or physical properties of pure iron, we have to discuss about one terminology, that is allotropy or allotropism of metal. Allotropy or allotropism of metal is nothing but the existence of pure metals in different forms of or different physical state. That is actually allotropy or allotropism. Okay, please wait. Okay, sorry. Okay, now Now, to better understand allotropism, I am not going to directly to the properties of iron. First, we can take an example of carbon about this allotropy or allotropism, because about these allotropism of carbon you have studied in your school. That is, some allotropic form of carbon is diamond or graphite or fullerenes. You have studied about these allotropic forms of carbon, because diamond and graphite having the different structural properties or crystalline structure, but both diamond and graphite is the same metal, that is carbon. These types of property of some elements, that is allotropy or allotropism, cannot be a form of some compound materials, that only be exist in elements, that may be metal or non-metal, but compounds don't have the property of allotropy or allotropism. Okay, now this type of different forms or different physical state of metals or non-metals are allotropism. That is, as an example, carbon having different forms or different state, that is diamond, graphite, graphene or fullerenes. Like these types of property is called allotropy. I think the property of allotropism is now clear, because you have the idea about carbon allotropism, that is different shapes, different structures of diamond and graphite. Now, now we can go to the property of pure iron or property of allotropism of pure iron. That is, iron have mainly three three allotropic forms or three different physical states. One is alpha iron, one is gamma iron, one is delta iron. And not very common, but there is another form or another state of iron, that is epsilon iron. Okay, but this form is not very much common, and in all the uh, samples of iron, epsilon iron may not be exist, but these three forms, that is alpha, gamma and delta iron, these allotropic forms are present in all the samples of iron. But the this allotropism is dependent on the temperature. Now, sorry. Now, these allotropic forms of iron actually depends on temperature, that I have already told. And first form of iron, that is alpha iron, or that may be called as ferrite, is occurs in temperature of 9 temperature up to, not of, up to 912 degrees Celsius from normal temperature, that is from atmospheric temperature or natural temperature to 912 degrees Celsius. This form of iron, that is alpha iron or ferrite, present in the sample, and this alpha iron have the structure of BCC structure. Now, the question is that what is BCC structure? I think you have studied in your second module of the subject, the crystalline structure. Uh, there are some crystalline structure forms, that is BCC, FCC and other. But if you want to know what is BCC structure, that is this. This one is actually BCC structure. BCC structure is nothing but a cubical structure. Atoms are present at the vertices of the cube, and one atom is at the center of the cube, and there is some angle actually, sorry, uh, these angles are specified for this cube, and this distance between the atoms are also specified, and in this case of ferrite iron, this distance between two atoms is 2.93 angstrom. This is the primary BCC structure of alpha iron or ferrite iron. Okay, and this type of structure may be occur in the temperature up to 912 degrees Celsius or approximately 910 degrees Celsius. Okay, but one important characteristics of iron is that up to 768 degrees Celsius or approximately 707 degrees Celsius, iron loses its property of magnetic property. Okay, that means after 768 or 770 degrees Celsius, that same form of iron, that is alpha iron or ferrite, this that is 770 to 910 or 12 degrees Celsius, this sample of iron will don't have the property of magnetism, or that iron will be non-magnetic iron. That means in case of alpha iron or ferrite, there are two different property of that ferrite iron, that is this part of temperature up to 770 degrees Celsius, the iron is magnetic. After 770 degrees Celsius to 910 degree or 12 degrees Celsius, the iron is non-magnetic, and total this part is in forms of or in crystalline structure of BCC structure, and this up to this temperature the iron is in form of or in state of alpha iron or ferrite. Okay, now coming to the next form or next state, that is gamma iron or austenite, austenite iron or gamma iron. After 912 degrees Celsius to 1394 degrees Celsius, that is temperature is rising. When the temperature is rising, obviously the crystalline structure of iron will change, and crystalline structure will change to FCC centered lattice structure, or you may remember it as FCC structure from BCC structure. BCC structure is in case of alpha iron. From this BCC structure, that will change in FCC structure or FCC centered lattice structure. And what is the centered lattice structure? That is this one. This one, this type of cubic structure with some atoms are at the vertices of the cube, and some atoms having some centerline construction. This type of centerline construction, from this centerline means centerline of the one square or one square surface of cube. This is one surface of cube, and this there will be one atom which constructs center lines of the structure. This type of structure is called centerline lattice structure or FCC structure. In case of this temperature phase, that is 912 degrees Celsius to 1394 degrees Celsius or approximately 1400 degrees Celsius, this temperature iron will be in form of FCC structure, and this is called gamma iron or austenite iron. Okay. Now, if the temperature will be increasing continuously, then after 1394 degrees Celsius, that iron will revert back to the same BCC structure but with some modification. That is that the form is called delta iron or delta ferrite. Why ferrite? Actually, ferrite is because the crystalline structure is same as alpha iron or ferrite. Crystalline form is crystalline structure is same as BCC structure. Here you may see that BCC structure, but with some modification, with the distance is some modified length of 2.87 angstrom, something like that. But the structure is same as or similar as BCC structure, that is in a cubic form. Atoms are at the vertices of the cube and one atom is at the center of the cube. This is that is the delta iron or the delta ferrite form or state is actually the reverted form of alpha iron, but in this case there is some modification in structure, and this form is called or this state is called delta iron or delta ferrite, and this form is actually occurs in case of 1300 beyond 1394 degrees Celsius to 1538 degrees Celsius or 1540 degrees Celsius maybe, and these 1540 degrees Celsius temperature is very much important for civil engineering structural material of steel, because 1540 degrees Celsius is the melting temperature of iron, and in this temperature iron is mixed with specific amount of carbon to make steel, the construction material steel. Okay, that's why this temperature 1538 or approximately 1540 degrees Celsius is very much important. Okay, now in this temperature obviously there is written that in this temperature the properties or characteristics of iron may be improved by addition of some other materials, and most importantly that is carbon, to construct the construction steel, and you may add cobalt or nickel also, because these are also magnetic material, and by that you may improve the properties of iron. These three form or state, that is alpha iron, gamma iron and delta iron, are the important state or important allotropes of iron, pure iron, important allotropes of pure iron. But in some cases, okay, this symbol I can change to epsilon. Yes, this one. Epsilon iron, this form or this state you may find in some cases or in some sample of iron, but not in all the cases. These temperatures are very much approximate, that may be occur in 1538 or 39 or 40, but in the range of that 1538 to 40 or 44 or 42, but not beyond that. After that, obviously, I have already discussed that the iron is in liquid state, but in this case, some of the iron may be in solid state also, and those samples or those solid sample of iron in liquid may be termed as epsilon iron or hexaferron. Okay, this is all about the allotropes of iron, allotropes of pure iron. Now, this is the graphical representation of allotropy of pure iron or allotropes, different allotropic forms of pure iron I have already discussed, and obviously this is the temperature axis. You may consider this temperature as approximate temperature, and obviously this temperature may be differ 1 to 2 degrees Celsius or 1 to 5 degrees Celsius in the practical cases. And now the same thing but in some systematic form, and obviously we have discussed about this in the previous classes, that is the phase diagram of pure iron. These diagram is actually the systematic representation of phase diagram of pure iron. I may largen the figure to better understand. As this is pure iron, then obviously this is in form of one element phase diagram. Obviously you may draw the one element phase diagram as this material is pure, that means no mixture or no alloy form is there. That means there is only one component, and one component phase diagram you may draw. In one component phase diagram there are two axes, one is temperature axis, one is pressure axis. For the recapitulation, in case of binary phase diagram, you have one temperature axis and one component axis. Pressure is constant in one atmospheric pressure, but there is no axis regarding the pressure. But in case of one component phase diagram, there is two axes, one is temperature axis, one is pressure axis. In case of one component phase diagram or phase diagram for pure materials, there is no component, no axis of components. And components are actually, as there is one component is represented here in the graph or here in the diagram. Okay. Now I have already discussed that these things, that is up to temperature 910 or 12 degrees Celsius. One form is there, that is alpha. After that, gamma form is there up to 1394 degrees Celsius, and after 1394 degrees Celsius to 1538 degrees Celsius, there will be delta iron. And after that, the iron will melt and in form of liquid you may get. And this this thing is vapor of iron. Why? Because there is less atmospheric pressure. I think I have discussed in some of my classes that in case of ice, there is some coexistence of solid and vapor, or solid and gas, because you may see that some vapor is coming from ice in case of low temperature and low pressure. In this case also, in this case of iron also, when pressure is low, that is 10 to the power minus 2 bar, or 10 to the power minus 2 1 bar is I think this is atmospheric temperature actually. When the atmospheric temperature is very low, 10 to the power minus 12, in range of 10 to the power minus 12 range, then you may get some coexistence of solid iron and vapor iron. Okay, and this is the systematic representation of phase diagram of pure iron. Now this is all about the phase diagram of pure iron and allotropy of pure iron. If you have any doubts regarding this, you may ask, or we can discuss about all those things.